This question is from GATE 2011 Mechanical Engineering paper question number 50. 1 unit of product P1 requires 3 kg of resource R1 and 1 kg of resource R2. 1 unit of product P2 requires 2 kg of resource R1 and 2 kg of resource R2. The profits per unit by selling product P1 and P2 are rupees 2000 and rupees 3000 respectively. The manufacturer has 90 kgs of resource R1 and 100 kgs of resource R2. The unit worth of resource R2, that is dual price of resource R2 in rupees per kg is. Let's write the given information first. So for two products P1 and P2, we have two resources R1 and R2. We can write for product P1, resource R1 that is required is 3 kg, while R2 that is required is 1 kg. For product P2, resource R1 required is 2 kg, while R2 required is also 2 kg each. Now total R1 resource available, R1 is 90 kgs, while R2 is 100 kgs. So there is a constraint on availability of R1 and R2. We can write this constraint in terms of the product units P1 and P2. So let's assume that X units of P1 are produced while Y units of P2 are produced. Now a constraint for R1 can be written as for production of P1 is 3 into X plus total resource R1 required for production of P2 is 2 into its total number of units Y. So 3x plus 2y is the total resource R1 required. This total should not be exceeding 90 kgs. So it should be less than or equal to 90 kgs. Because the total availability is 90 kgs, so we cannot use it more than that. Similarly for R2, we can write this constraint as x plus 2y is less than or equal to 100 kg. So we have formed the equations for constraints. The thing that is asked in this question, which is unit worth of resource R2. Unit worth of R2 indicates the marginal price for R2, which indicates the increase in the profit if we increase 1 unit of R2. So for every 1 unit increase of R2, how much is the increase in profit? Is nothing but the unit worth of R2. To calculate this, first we will have to calculate the profit at what units x comma y is the profit maximum. That is what we will calculate. We'll use the graphical method to calculate it. Let's plot the constraints. 3x plus 2y is less than or equal to 90 kg and x plus 2y is less than or equal to 100. So to plot the constraints, let's put x equal to 0. We'll get y as 45. So on y-axis the point is 0, 45. While when we put y equal to 0, we get x as 30. So on x-axis the point will be 30, 0. This is the line. Let's plot the second constraint. When we put x equal to 0, y is 50. So we have the second point as 50 here. 0, 50 here. When we put y equal to 0, we get x equal to 100 itself. So this point is 100, 0 here. Now we have taken the equality, limiting equality to calculate the x and y values. That's how the equation will be plotted. So the line that passes is this yellow line. Now there are two more constraints on R1 and R2. That is, they cannot be negative. So R1 should be greater than or equal to 0 and R2 should be greater than or equal to 0. These are the additional constraints that we need to figure out because R1 and R2 are resources in kg. So definitely they can't be 0. The feasible region or the overlapping region for both of these axes we can find out by taking first the region under this and then the region under this. So this quadrilateral belongs to only the second constraint while this area belongs to all 4 constraints. So this is our feasible region. We need to find out maximum profit. So let's write the equation for profit Z let the profit be Z. This will be equal to per unit profit of P1 is 2000. So we can write 2000 into X is the total profit from product P1 plus the total profit from product P2 is 3000, which is per unit profit, into total number of units Y. So this is the profit. We need to maximize the profit. That means we'll calculate value of Z at each of these node points. So this point is 0, 0. Anyway, the profit will be 0. So Z at 0, 0 is 0. This is not, of course, the maximum value. We'll calculate Z at 0, 45. So we have 2000 into 0 plus 3000 into 45. This gives us the profit to be 1,35,000 rupees. If we calculate it for 30, 0, we get the profit as 30 into 2000 plus 0, so which is 60,000. So clearly we can see that maximum profit that we obtain is rupees 1,35,000, which is for 0 units of product P1 and 45 units of product P2. Now, to calculate the unit price of R2, if we increase 1 unit of R2, that is, if we increase the resource R2 by 1 kg, we change this 100 to 101. What will be the change in the profit? If we change it to 101, this point will shift as well as this point will also shift. So the constraint of yellow line is shifting outwards. But will there be a change on the feasible region? No, there won't be a change on the feasible region because the overlapping part will remain the same. So Z remains same irrespective of increasing R2 by 1 unit or 1 kg. That is why we can say unit worth of R2 is 0. Of course, if we increase the unit R1 by 1 unit, then the change will be seen because we are shifting the inner constraint here. So the feasible region will change. But as long as R2 is considered, making the total availability 101 kg will not change the profit. It will keep the profit same. So let's go back and mark the correct option. Unit worth of resource R2, that is dual price of R2 in rupees per kg, is 0 here. To learn more about graphical method of optimization, you can refer to the NPTEL video graphical method maximization from the course Introduction to Operations Research. This course is by Professor G. Srinivasan. He is from IIT Madras. I hope this solution will help you clear your doubt. Thank you.